Thanks for coming. So I just made this slide yesterday, but I was told by a team member, this guy actually died yesterday. So I dedicate this talk to BOZO the clown, because why not? Yeah, too soon, sorry. So the other BOZO the clown here, been at Amazon only 15 months, was on Sculpin, working out of San Diego, switched to the Dragonfly team, but I still work from San Diego. Started out in the industry in the mid-90s on PlayStation 1 using C and assembly language where performance super important. Moved to C++ in 2000. The platform still sucked, so performance was still important. There's my likes and dislikes. Why review code? This is a list of kind of what I get out of reviewing people's code. Number one thing is I find lots of bugs in people's code. Code review time is the best time to nail that bug down. If it goes out in production, might be a day, a week, a month, a year, never found. But if a bug manifests itself months from the code review, it'll take a lot longer to find it and fix it. In the meantime, the bug may have gotten worse. Sometimes I'm finding in code reviews, people are in 10 lines of code doing something that like, oh crap, they could just do this in 1 line of code. And if you shorten a bunch of things in the code, you can see a lot more per screen rather than having to page around stuff that was excessively long. I'm finding a lot of things that could be done more efficiently as far as CPU time goes. Things that maybe people weren't aware of because Windows lets you throw pretty much anything at it. Design review also can happen at this point. It's a little bit hard because you're not necessarily in that person's mindset to know what they were thinking for their design, but you might have some insight that they weren't aware of, and now's a good time to point it out before they go too deep down a rabbit hole. It's good to become with other parts of the code that aren't yours. You never know when you might need to deal with their code someday, and you'll remember some of their code reviews and remember, oh, they did it this way. I know exactly where to go. Also, there's a little tit for tat. If you want somebody to review your code someday, review theirs. Then they'll feel some obligation. Some things to keep in mind. If someone does post some comments on your code, respond. Don't take any of it personally. All of our code sucks. Mine does, yours does, everybody's does. If you think somebody's picking on you, you kind of have the last laugh because you know that their code also shit. It's true, we all know it. Don't be afraid to look at code that isn't what you're familiar with. You might not understand the high level of what they're doing, but I mean, it's ultimately code. You can understand probably a particular line of code. So if you go through something line by line, you might spot stuff that they missed, some parameter that they should have used but didn't. Worst case, it's a false positive. You point out something, hey, did you mean to do blah? They might say, no, that was meant to be. Or they might be like, holy crap, you're awesome, thank you. You just fixed something and saved me some headache later on. So since I've been at Amazon for 15 months, I'm at around 850 code reviews that I've done, vast majority on the Dragonfly team. I didn't scour my email to do any kind of analysis about how many are the top 10 and in what ranking. So this is just kind of my impression and some input from team members. Misspellings. I'm sure this is a pet peeve of any of us kind of anal retentive spellers, but it's important if you use any kind of search and replace tools, because if you spell it right, you're not going to find a lot of shit that you would have loved to have found. Anybody know where the misspelling is on that last one? It's a trick question. The last one, milliseconds, should be centiseconds. A lot of people don't realize that Booleans are first-class citizens. They're comparing things to true and false when the thing itself is true or false. You don't need to explicitly do it. So the white lines of code are what the person originally programmed, and the yellow is what I suggested. Those last two examples are great because you can say in 1 line of succinct code something that they took 3 or 4 lines. You don't have to test a condition or to return true or false. You can just return the condition or the opposite of the condition. In Lumberyard, we have an AZ standard rather than just the typical C++ standard. A lot of people new to the organization don't know that, understandably, so they just default to using STD, not the sexual disease. So you just kind of nudge them that, hey, we have this thing, it's called AZ STD. There are only a couple things that I found missing, like string stream. We use a lot of that in our code. Unfortunately, we have to use the STD version of that. It'd be nice if we had AZ STD. There's algorithms that are in the C++ standard that also exists in the AZ standard. Stuff like there's 10 or 15 lines of code. Somebody's just merely looping through a list, looking for a particular one. There is AZ standard : find or find underscore if. In one line of code, you can do the exact same thing. And if you're looking through your code or somebody's looking through your code, they can immediately see that you're finding something. Whereas if you look at the sort of unrolled version of that, it might take you a few seconds to kind of work out what they're doing. So it saves time and also saves lines, saves lives, maybe. I blame colleges that suck now by teaching only Java and C# for this. Everything is passed by value. Oh, did I just say something controversial? Guess what? I don't care. Pass by const reference. You avoid copies. You avoid all sorts of things. That's if it's something bigger than a register size. Anything register size can be passed directly, and I would not be mad at you. On the opposite end of that, receiving by const reference instead of just by value, you avoid copies. A lot of people don't know this. I didn't even know this until last year. Anything that's returned as a temporary, you can receive that into a const reference. That temporary will stay alive for as long as the const reference itself is alive. That is super awesome. This particular issue is minimized a little bit by the fact that we have move semantics and also R value or return value optimizations. You're not guaranteed that a compiler implements RVO though, although that's probably pretty rare these days. But the other thing is there's some cases where they can't implement it. And unless you sort of learn up on what are those cases and search for the implementation of every function you want to call, I don't have that kind of free time. I'm just going to use const reference to receive it and be done. This is a famous one. I'm sure everybody is not surprised here. Lots of copy-paste stuff. It's probably something that could even be automated on a check-in. Just taking a chunk of code, pasting it, changing a few things. Oh shit, there's one thing I did forget to change. This is another one that Java and C# I blame. That everything is new. So I come across a lot of cases where somebody's allocating something on the heap instead of the stack for just some kind of local operations. Unless something is massive, it can live on the stack. You avoid any new and delete. There's performance implications there, especially if it's in a critical piece of code. And unless you're using a smart pointer, you have to remember to delete. And you have to remember to delete in the right spot or spots. So you could cause yourself some trouble if you don't do that correctly. So let it live on the stack, please. This is another one that I'm finding people aren't realizing. A lot of functions have a floating point version if you just put an F after it. If you don't, it's the double version. We're almost exclusively using floating point, not doubles. If you call the double function, it has to convert the float to a double, and then it does the operation in double space. And then the return value is a double. And if you're receiving it into a float, it has to do a conversion there. That sucks. Just put an F after there, and I will smile. This is something we find a lot on our team. People are afraid to debug in a release build, so they will locally leave it optimization off, and then they check in their code that way. We don't like that. So we have some tools that help us, so you only have to locally specify that to be the case. Thank you.